Okay, so we talked before about graphing a quadratic just from a standard form, which, that standard form is y is equal to ax squared plus bx plus c. And one of the things that we've seen is that once you have your vertex and know a little bit about, especially that leading coefficient, it's fairly easy to graph. It's relatively straightforward to graph. So let's talk about how to convert from this standard form to a vertex form. And the vertex form is just that y is equal to a times x minus h squared plus k. We also know that the h is equal to negative b over 2a, and that k is just that function at h. This is just the y value associated with the h. So let's see, what would we like to graph today? How about we graph or how about we do y is equal to x squared minus 4x plus 3. And here, I'm going to go ahead and find that vertex. So I'll already note that a is equal to 1, b is equal to negative 4, c is equal to 3. Oops. C is, of course, equal to c, but yeah, c is equal to 3. So my h is going to be negative 4 over 2 times 1. Negative is positive. So I'll have positive 4 divided by 2 is a 2. The k is therefore where I just plug in my h value. So this is going to be 2 squared minus 4 times 2 plus 3. So looks like my k is going to be 4 minus 8 plus 3. So this is going to be negative 4 plus 3 is a negative 1 is my k. So my vertex is going to be 2, negative 1. This is my vertex. Now I'm going to plug this in to my vertex formula. My a, so y equals a times x minus h squared plus k. My a was 1, so I'll just say y is equal to, I'll put a 1 there for the time being. X minus h, that's going to be x minus that 2. And then plus a negative 1. I'm going to go ahead and resolve the signs. I don't need the double set of parentheses here, and I don't need it there. So this is just going to be y is equal to x minus 2 squared minus 1. This is what this is going to look like. So if you're just reading an equation like this, notice that we're essentially having to flip the sign inside the set of parentheses. So even though this says minus 2, we already know that our vertex is a positive 2. And we know that the y value is still a negative 1. So this is negative h, and this is our value of k. So there we have it. And now we have everything that we need to graph, because you just need to know the a value and the vertex. Let's do it. This was y is equal to x minus 2 squared minus 1. So we've got a vertex of 2, negative 1. Here's my x, here's my y. So it's 1, 2, and down 1. And now that I have my vertex, I can move out from that. As soon as I move out 1, it's going to move up 1 squared. If it moves out 2, 1, 2, it's going to move up 2 squared, or 4. So from this vertex, it moves 1, 2, 1, 2, 3, 4. If it moves out 3, 1, 2, 3 in either direction, it'll move up 3 squared, or 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're done. So this has that same shape as any x squared. So remember, you're going to graph your vertex. Then you're going to count out from the vertex and then up a times, so that's a times the square. So what? So 1 times 1 squared is just 1. 1 times 2 squared is 4. 1 times 3 squared is 9. Let's do another one. Let's say I've got y is equal to x plus 2 squared plus 3. All right. This is my minus h. This is my k. So my vertex is at -2, 3. One, 2. And here it's going to be 1, 2, 3. This is up above my x-axis. This one would be an equation that would have no x-intercepts. It moves out 1 and up 1. It moves out 2. It moves up 4. 1. So 1, 2, 3, 4. It moves out 3. 1, 2, 3. It moves up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So somewhat above where I had drawn my axes even. So that vertex there, -2, 3, and every point, it moves out 1, moves up 1 squared. Moves out 2, moves up 1 times 2 squared. Moves out 3, moves up 1 times 3 squared. All right, this seems like a pretty good place to end this video. So I'll see you in the next one.